halogenation and halohydrin formation. Halogenation is the reaction of an alkene with the halogen, giving it the name of halogenation. Just remember, halogenation means a halogen reacting with an alkene. Usually it's with bromine or chlorine. Let's talk first about the mechanism here. We have cyclohexane reacting with the bromine atom in order to perform what's called halogenation. In the first place, we have the double bond of the cyclohexane, which is acting as a nucleophile, meaning that it's negative. It's going to attract the bromine atom, which is the closest to it. It's going to attract it, making it partially positive, and the bromine atom, which is from this side, is going to pull the electrons of the bond toward it, making it very electronegative here. So in the first place, we have the double bond of the cyclohexane, which is going to grab the bromine atom, which is partially positive. Since it's negative, it's going to grab the one which is partially positive toward it. And then we have the making the double bond single bond, breaking the double bond. So we have one of the carbons here, which is positive, since we have a single bond from a double bond, like a double bond breaking into a single bond. So we have one carbon which is lacking an atom or a bond. So here we have the lone pair of the same bromine atom is going to attack the carbon which is partially positive. I mean, one of them. If the first bromine atom, the first link is to this carbon, the other one is going to be to this one. If the first bond with the bromine atom is this one, the other bond is going to be with the other carbon here. And since it's bonded to the cyclohexane, the bromine atom, which is partially negative, is going to leave. It's the leaving group here. So here we have the bridge, which is formed with one bromine atom and the two carbons of the cyclohexane, in this case, is forming the bromonium ion. And here we have the carbons of this bond here, which are partially positive. They are partially positive because they are lacking another atom, another bond. So since they are partially positive, the other bromine atom, which is negative, is going to attack one of these carbon here, and the other one, the other bond will break. So we're gonna keep one bond with this bromine, and we're going to keep one bond here with this bromine. Since it was partially positive, it's going to be just neutral after adding the bromine atom, which is negative, and this is partially positive as well. So if we break this bond with the bromine atom, it's going to be stabilized, each with one bromine atom. So here we have two bromine atoms linked to cyclohexane. But here the halogenation and halogenation reaction is not radioselective, but it's an anti-addition reaction. An anti-addition reaction means that if there is a chiral carbon which is formed after the halogenation, we have some priorities. So here we have this alkene linked to a bromine, giving us one chiral center since it has bromine, and a methyl, and another here, an ethyl bonded to a bromine and hydrogen. Four different things, it's a chiral. So the anti-addition reaction says that when you have a chiral carbon, you have two main options. So here we have the bromine will attack this atom from this side or from this side. We have two main options. So it can be going to the front of the page, or it could be going to the back of the page. We have two racemic mixture, 50%, 50. And here we have the cyclohexane reacting with the bromine atom, giving us two bromine atoms bonded to a cyclohexane. But here we have two options as well, since each of these carbon is a chiral. So we have this option here. The first bromine is going toward us, and the second one and the bottom is going to the back of the page, or the second option, which is the first one, is going to the back of the page, and the second one, which is going toward us. That's what's called an anti-addition reaction. So we have a racemic mixture, 50% from this one and 50% from this one for halogenation reaction. Now let's move to a halohydrin formation. Just remember, when it says halohydrin, meaning that we have a halogen, and hydrin meaning like hydration, water. Just remember, hydration, hydrin, water. So we have here a cyclohexane reacting with water and halogen, or it's reacting with the halogen in the presence of the water molecule. Here we have two options. Here we let's talk about the mechanism first here. Yeah, so for the mechanism for this reaction, we have cyclohexane reacting with the chlorine atom. As we said earlier, for the bromine atom, when we have two chlorine atoms, the closest to the double bond is partially positive, because the double bond is acting as a nucleophile here. So this chlorine atom is partially positive, and the other one is partially negative, because it's pulling the electrons of the bond toward it. So here we have, for this reaction, in the first place, we have the double bond, which is going to grab the chlorine atom, which is partially positive because it's negative. And in the second place, we will have a carbon which is lacking one bond, since we had a double bond and then we linked a chlorine atom to one carbon, which is okay, like making it like 4 bonds, but the other one is lacking another bond, so the lone pair of the chlorine atom is going to attack the other carbon, making a bridge. It's kind of bridge here. So here, since we have bridge, we have two carbons which are partially positive each. In the second place, the water molecule is going to attack. It's acting as a nucleophile, is going to attack the one which is partially positive, the one like the closest here. If it goes from this side, we have the bridge which will block it. But if it goes from this side, this is more accessible to the water molecule here. So it's going to be linked to a water molecule, and this chlorine is going to leave. It's the leaving group. And here we will have a cyclohexane, which is linked to two chlorine atoms and water here. Yeah, so we have H2O, but it's partially positive because it's linked to, the oxygen is linked to 1, 2, 3 molecules, so it's partially positive. The other water molecule is going to react to grab the proton from the H2O, which is linked to this carbon here, making it H3O plus, and then we have an OH, just an OH here with the methyl group. We have the methyl group. So the bridge will break, and then a chlorine atom is going to stay on that carbon, and the water molecule is going to stay on this one here. So here we have an OH, and here we have a chlorine atom. This is the first case. But if we have here instead of having water, we have alcohol, for example, here, or CH3, CH2OH. Like always, we have, instead of having OH linked to that carbon, we will have an OR. We'll just remove the H, because actually it's the H which is grabbed by the solvent here in order to make it neutral rather than positive. So rather than having an OH here, we're going to have an RO, not an OH. Because remember, OH is H2O minus 1 hydrogen. So if we have an ROH, is going to be an ROH minus the hydrogen. It's going to be an RO. So let's talk about stereochemistry here. If we have cyclohexane reacting with the chlorine atom in the presence of water, as we explained, we're going to have an OH and a chlorine atom. But here, since the chlorine, it's an anti-addition reaction, so we have the chlorine in the less substituted side and an OH in the more or the most substituted side. It's not a Markovnikov rule, but this is the rule. The OH is always placed on the most substituted side, like here it's a tertiary carbon, and the chlorine is placed on the less substituted side. Here we have secondary carbon. So here we have two chiral centers for stereochemistry. This is a chiral center and this is a chiral center. So here we have, since it's an anti-addition reaction, we have the chlorine. We have two options. The chlorine is facing us. The OH is going to the back of the page, or the OH is facing us and the chlorine is going to the back of the page. That's what we're going to have here as a result. Going toward us, the chlorine to the back, or OH to the back. Sorry, here it's dashes. To the back and chlorine towards us. So this is the halohydrin formation. Thank you.